Hi good people, my name's Titus and today we're going to be creating a basic AI in Unreal Engine using behavior trees and blackboards. The behavior tree contains branches of logic to be executed and the blackboard contains user-defined keys that hold information used by the tree to make decisions. Alright, let's not waste any time and just jump right into it. So first thing we're going to do is set up our project so we can right click, create a new folder, and we'll call it _AI. Then I'm going to go into the third person folder, select blueprints, and I'm using the third person template. So I'm going to be stealing the character component of that. So I can just simply drag this into the AI folder, and I'm going to do a copy here to make a duplicate. If I then go to my AI folder, I can select that and press F2 to rename it, because this is going to be my enemy. So I'll call it BP_enemy. The next thing we need is an AI controller, so we can right click, select a new blueprint class, and then under all classes, search for AI controller. We'll go ahead and select that. And then for a title or a name, I'll give it BP_enemy controller. With that created, let's go ahead and make some adjustments real quick to the BP enemy. So we'll double click to open that up. Because we stole this from the player character, I'm just going to select all the code and delete it because we don't need it. The next thing I'm going to do is I'm going to select the BP enemy self, and then if you scroll down near the bottom, there is going to be a pawn section. There's a few changes we need to make. We're going to be using the controller's rotation settings, so you'll want to check the rotation yaw so the player's able to rotate off our blackboard value that we're going to set up in a second. The other important change we need to make is the AI controller class. We're going to change that from the default of AI controller, and we're going to use our custom BP_enemy controller. The other important call out is the auto possess AI. Currently I'm set to placed in world, which is going to be good for me because I am literally dragging and dropping this into the world. But if your prototype or your project, it has you spawning the enemy in, then you'll want to actually change this to spawned instead of placed in world. Okay, with that set, there is one other thing we need. The AI controller is going to be using a nav mesh. Currently in the level, all we have is a post-process volume. So let's hit the add button. We'll do nav mesh bounds volume. You can drag that into the scene. And then I'm going to press R and scale it up along the Y and the X, and then also the Z. I'll go back to W and just position this a little better, maybe right about there. That looks okay. And maybe I need to rotate a little bit more this way. Somewhere around there. With the nav mesh selected, you can press the P key to get a view of all the navigation data that the volume will give you. So this looks pretty good. We're basically going to use this system to drive the movement of the actual player here. Go ahead and press P to hide that. Okay, so now we have our enemy and our controller and our nav mesh set up. So next what we can do is we're going to create the blackboard. So you can right click, select artificial intelligence, and then blackboard. Call this BB_enemy. And then we'll double click to open that up. This is basically the brain of your AI. So you got to figure out what logic you want your AI to do. And then depending on that logic, there's probably going to be certain values that you're going to need to store. And that's where you store it in the blackboard. So in this example, I want my AI to patrol an area. And then if they see the player, I want them to chase him. Be a very simple demonstration. So I'm gonna need a couple things. I'm gonna need some patrol locations. Those would be a vector, right? An X, Y, and Z. So I'll need a vector key for patrol. I will need a Boolean key for when the enemy sees the player, basically mark true and false. And then I also need to know the location of the player to be able to move towards them. So I'll need an object key as well, which will be the player. So we'll click new key. The first one we'll do is object. And I'll call this player actor. And then I'm going to select that. And in the key type, I am going to change the base class from object to actor, just because our player is an actor, so that'll be a little bit easier. Then I'll create a new key. We'll do a Boolean, and I will call this as line of sight. And the defaults are just fine. We'll do one final key called vector. To give it a name of patrol location. And the defaults for that will be fine. This will be where our various random locations that the players or the enemy is going to move to. And then we'll save that, and that is the entirety of our Blackboard setup. So that's pretty easy. What's a little bit more difficult is the behavior tree. So we'll go ahead and right-click Artificial Intelligence and select Behavior Tree. We'll call this BT_enemy. And then we'll double-click to open that up. It works just like an event graph, so we'll basically just be placing some nodes around. Let's pull off the root node and add a selector composite. The selector we can call AI root. And then off the selector, we're going to do 3 options. The first 2 will be sequences, so we'll select the sequence there. And the sequence that we'll give the first one is chase. And then the second sequence, well, I guess the second and also last sequence will be the patrol. And then the third option is actually going to be a task. So we have some built-in tasks that the behavior tree can do, one of which is wait. And this one I'm going to set for 1 second. The way behavior trees work is it executes top down, left to right. And also it's pretty handy if you look in the top right corner of each node, it gives you an index value or a number. And that indicates the order of operations that it's going to go through your branches and your nodes. So it's obviously going to start at 0, which is the AI root. And then it's going to move into chase. It's going to try to do chase first, and then it'll move into patrol, and then it'll move into wait. The important part about selectors and sequences is a selector will basically execute logic as long as it's successful. So as soon as you get if any of the children in a selector is successful, it won't mess with the rest of them. It'll just basically execute that branch, and then you're done basically. The sequence is kind of the inverse of that, where it'll execute as long as one of the children don't fail. So if it fails, then it kicks it back. So they're kind of inverses there. So for the chase sequence, what we can do is I want my AI to turn towards the player. I want them to then update their movement speed to running, and then I want them to move towards the player. So it's going to be 3 actions basically. So the first one, there's a built-in task called rotate to face Blackboard entry, which is perfect. I can use that, and in the Blackboard key, it has a reference to itself, which is the enemy, which is not right. I want that to be the player, so I'm going to change that to player. After we rotate towards the player, I then want to change the movement speed of the enemy. Now, if you look in the defined tasks, we actually don't have one that a defaulted one that's going to do that. But that's okay. You can create custom tasks by just clicking the new task button at the top. So we'll select that. We'll call it behavior tree task or BTT underscore, and then we'll do maybe chase player. With that created, I can go back to my tree, drag off, and you'll notice that BTT chase player now shows up as an option. There's nothing in the details panel, and it's because we haven't defined the logic. We will do that after we set up our tree. After we set the movement speed, we want to actually move towards the player. There is a built-in task for that, and it's just move to. In the move to section, there's a Blackboard key. Right now it's trying to reference itself. I don't want the enemy to move towards itself because that doesn't make a lot of sense. I want it to move towards the player. So that's going to be the logic for the chase sequence. Now let's work on the patrol. The patrol is also going to be a custom logic because we need to get a random vector location around the world or the map that we're on. There's not a defaulted one that's going to do that, so we need to make another custom task. So we'll do new task, and we'll call it BTT underscore find random position or POS. And we'll go back to the tree, drag off, and then find random position shows up. Again, we don't have any values because we haven't coded any logic, so we will get to that in a second. So once we find a random position in the map, I want to move towards that location. And then for the location key in the previous one, we chose the player. In this one, you probably figured it out. We are choosing our patrol location because remember on our Blackboard, we set that as our vector. So that's where it's going to pass in the value. So pass it in here, the tree will move it over here. And then after we move towards the position and we get there, we then just want to wait. So we'll use another wait task. This one's going to be a little bit longer than 1 second. We'll maybe wait 4 seconds with a 1 second deviation. So basically, it'll be anywhere between 3 and 5 seconds. And then after that, we're pretty much done. And this is the logic of our behavior tree. So not too bad. Now that we have our behavior tree kind of set up, we can start defining the code that we created on some of these custom tasks. So we have 2 custom tasks that we need to write. Let's work on the chase player first. For the chase player, I want a variable stored called the chase speed. This is going to be a float. And then I also am going to set this to be instance editable by clicking the eyeball. You can also go to the right-hand details and just check the instance editable button either way. The chase speed, I'm going to do 700. I think the default walking speed is 500. I'm going to do the patrol speed around 250, and then I'll do the running chase speed at 700. And that'll be how we kind of set that up. If you search for a node by right-clicking and just search for execute, there is an event receive execute AI. That's the one we want for the event. And then we can basically pull off this into a cast to our BP enemy. We'll pass the control pond into the object field. Now with behavior trees, and specifically with sequence nodes, we need to be able to tell the sequence, especially if it's custom logic, you need to define a pass-fail scenario. If you don't, you're going to get, if this enters in this branch and it executes the logic on your custom task, there's no way for the tree to know if it basically is done or if it, if it was successful or if it failed. So you're basically going to get stuck there. So the way we define that is we use, I'll pull off the failed here. We'll do a finish execute. So on the fail node, I'm going to set that to be success is false. And on the true value, I'm going to set that to be true. And then we're going to hook up this pin in a second. So this is basically how you can define your custom task to let it know, or let the behavior tree know that, this operation is complete and it failed, or this operation is complete and it was successful. That way it's able to, move on through its decision tree. So always make sure you include those. Now I could pull off this and just update the movement speed as the enemy, because it does use the movement component. But another way we can do it is we can actually just set that in the enemy as a custom event or a custom function. It doesn't really matter which. In this example, I will just do a function. So we're going to go back to our enemy, and then in the event graph under functions, I'll hit the little plus sign. And we'll do this as update walk speed or movement speed or whatever. And then in the input pins, I want to add 1 input. It's going to be my new walk speed, and this will be a float. And then I can just grab the character movement. And the setting on the character movement script is max walk speed. And then we can just basically pass the value through, and then this is basically done. So now when we go back to the chase player as the enemy, I can pull off that into the update walk speed function we just made, or if you made it as an event, either way. And then I can hook up the finish execution pin here like so. And then we just need to do a new movement speed. So this is the chase. So I'm going to drag my chase speed in here, and then we'll pass that in like that. And this is basically the code for our first chase player task. So this one is done. Now our next one is going to be the task for finding a random position on the map. This one's a little bit more complicated, but I'll step you through it. The beginning steps are the same, so we're going to right click, search for execute, and then event receive execute AI is the node. And then we're going to do the same thing as we did before, cast to BP enemy, pass the controlled pond into the object. And then as the enemy, we want to update the walk speed. The walk speed I want for this is going to be our patrol speed. So we're going to promote to a variable. We'll call this patrol speed. I'm also going to make this instance editable, compile. And then for the default value, I said I was going to do 250, I think. Be a nice slow kind of walk. And then on the cast failed, remember, we need to do the finish execute node, and we'll set it to false. Now on the true pin, we need to get a random location on the map. There's a bunch of ways you can do that. Just for simplicity, I'm just going to do a simple get random reachable point and radius. And then what I can do is, as the controlled pawn, I can pull off that and get the actor location. And then I want to basically create a circle from an origin point. The origin point is going to be the enemy. So we'll start from the enemy's position, and then we'll do a radius of a circle. So we can promote this to a variable called patrol radius. I will also make this instance editable, compile, and then for a default value, I'm going to try 2,000 units starting off. We don't need to worry about navigation data or filtering. I then want to use a branch check, so I'm going to press B, click on the graph, pass that in over here. And the reason I want to use a branch check is because this node sometimes will fail. Like it'll try to query the way this is working is it's using that nav mesh bounds volume, and it's basically getting a like a random point. So there might be a spot where it fails or where it doesn't kind of catch the logic. So we need to basically account for that edge case. So we can pass this in over here. And then if it's true, we can pass in that random location. If it's false, we can use the existing location. That way we're covered in kind of both scenarios. Now, what we can do is off the true pin, let's do a set blackboard value. And you have a couple different options. Remember, this is the finding the random position for the patrol. So the blackboard value we are going to be editing was a vector. So we'll do as vector. So if it's true, we'll pass in the random location here. And then we will press Control D to duplicate this node. And if it's false, we are going to pass in the actor's existing location. That way we account for any weirdness. Now we need a variable, a variable key to be able to set the blackboard. So what you can do, and this one's a little weird, but you can right click this, promote it to a variable, and just to show you that this is different, I'm just going to call this location key, and I'll make this instance editable. And then I am also going to drag this one into this slot here. Oops. And we can do it like that, I think. Okay, so we can compile like that. You notice location key default value is set to none. This is actually where you pass in the value for your blackboard. The way we can do it now that we have it set it up here is if we go to the behavior tree, because we publicly exposed it, in the find random position, you see there's a location key setting here, and currently it's defaulting to the enemy's position. Instead of that, we can set it to be the patrol location. Now, because we do that, it'll pass that value into the patrol location vector, which you can use in its decision tree. And then you can notice in the chase player, our chase speed is also editable from the behavior tree now as well. Let's go back. There is one final thing that we need to do. Remember, we defined a failure execution, but we have not defined a success. So we can press Control D, mark this as success, and we can hook up both of these pins. That way the behavior tree will have a pass-fail condition, and thus it'll have some way to exit the logic there. Because if you don't do that, it's not going to work. All right, now that we have that done, we can come to the most complicated part of this whole setup. And that is going to be the enemy controller. So if we double click to open that up, we can begin coding this. The enemy controller, we're going to use a special component inside Unreal Engine. So we'll hit add, and it's called AI Perception. If you select AI Perception in the details panel, you can configure the various senses related to the AI Perception. You can do like sound, sight, damage, a few different things. So we're going to add a single element. The option we're going to do is AI Sight. And then there is one change we need to make in here, and that is the detection by affiliation. We are going to set the detect neutrals because all objects are default neutral unless you specify otherwise. And we are not using the affiliation system because it is outside the scope of this video for now. But this would essentially be used for something like a prototype where you have player versus player and there's AI teammates. And they need to know who's enemies, who's friendlies. That way they can do different logic, that sort of thing. But with detect neutrals set, we're basically good with that part. So now we can begin coding the logic. So we'll delete the default nodes. And then if you search for possess, there's an event on possess. When we possess, we can just run the Blackboard. Or sorry, run behavior tree. And the behavior tree is the only one we created, which is BT_enemy. And then the next piece of logic we need to do is when the AI sees the player. The way we can do that is you can actually just highlight your AI perception, scroll down, you have a list of events that are available. We're going to do the on target perception updated. And from there, remember before we're not using the affiliate system, so I'm just going to do basic tagging. So we'll use a player tag to be able to check the actor. So we can pull off the actor and do actor as tag, and then we'll just search for the tag player with a capital P. This will not work because I have not set up the tagging inside the third person character blueprint. So we'll have to do that at the end. So just calling it out now. And then we're gonna pull off this into an AND Boolean because I need to check two things. I can pull off the stimulus into a break. And then if we expand out the options here, there is a successfully sensed. So I will drag this in here. And then with this highlighted, I can click the button to hide unconnected pins. So basically what this is doing is if it saw something and that something has a player tag, it'll return true. So I can basically hold the B key, click in the graph to add a branch node, hook this into here, and then we'll hook this like that. Now if we saw something, let's just do a debugger string. So we'll do print string, and we'll call this I see you. Make it simple. And then on the false pin, we need to set a timer. So we'll do set timer by, you can do function. In this example, I'll do event. The timer, what we can do for this is we can actually right click, promote it to a variable, and we'll maybe just call this line of sight timer. And then for a default value, I will set that to maybe 4 seconds. Push this forward a bit. All right, and then we can basically run some custom event based on this timer. So the custom event we'll do is going to be start enemy timer, and then we'll pass this value into here. And then maybe we will also right click and promote this to a variable called enemy timer, because we will likely need to reset this a few times. What we are doing here is we are setting up the logic for when the player gets seen by the AI, and then the AI or the player is able to break line of sight from the AI. How quickly do you want the logic of the AI to go back to patrolling versus still chasing? So if a player rounds a corner, we're saying for 4 additional seconds, chase after the player anyways, even though you can't see him. And it's basically going to do that through the, because it knows where the player is all the time, whether they see him or not. And this is kind of a little, just, you can kind of play with whatever values you want, but it's giving us that additional functionality where, we can continue to chase, even if the player rounds a corner, it's not immediately going to go back to its patrol route. And you can do different things with this, but that's effectively all this code is going to be doing. So what we need to do is we need to set the Blackboard keys for both the fail condition and the true condition. The way we can do that is you can right click and you can search for Blackboard. And then if you scroll down the bottom under the variables AI, there is a get Blackboard function, or node, I should say. So with this variable in place, we can basically pull off that and do a set value as, and then you see we have all our Blackboard keys. And we're seeing these even though we're not in the behavior tree task like we were in the other one. We're in an AI controller, so this is basically how we can get these references. So we can set the value as a bool, and then we also need the one for the object. So if I duplicate this, and then I set value as object, because remember the object is going to be the player. So we need to update the Blackboard key to which player they're going to be chasing. So let's move this up here and this up here. Now the key part is kind of confusing. All kind of, there's like 2 values with the keys. It'll probably be easier if I just show you. So for each key value, you can just basically right click, promote it to a variable. You can call it whatever you want. Like example, CU will be for this one. And then if I promote this one to a variable, we can just call this player. And if we compile and save, when I select each of these keys in the details panel, you see the variable name here, right? That's where you can make whatever you want it to be. But the default value at the bottom, this is what has to match on the Blackboard. So for the first one, this is the Boolean value. If we go back to our Blackboard, our Boolean value was has line of sight. And then if we go back here, the ICU needs to be has line of sight. So that's what has to match in your actual Blackboard entry. The player object, if we go back to the Blackboard, it's called player actor. So we will call this one player actor. So that part's was a little confusing to me. So just, be advised that these things technically they kind of have 2 variables. You can make them the same name if you want, if that's easier. That also might be a little bit confusing. But just know that basically the variable name can be kind of whatever you want it to be. And then the default value is the target on the Blackboard that you want to hit. And remember, this is the fail condition. So we're setting a timer to run this every 4 seconds, this event. And what this event does is it basically sets has line of sight to false. And it empties out the player object reference. It sets it to nothing or null. So there's no way for it to chase anything. Now what we can do is we can select all those nodes, press Control D to duplicate them. And then on the true pin, we basically just have to do the opposite, right? So we want to set this bool value to true. And then we want to pass in the actor object reference, which we can do because we have that right here. So we can just drag this over here And that's done like so. And this is basically the entirety of the logic for the enemy controller. So now what we can do is we can compile and save. If we play this, still it's kind of going to work. He's like patrolling, but you'll notice he doesn't see me. Right, we should get that print screen in the top left corner when he sees me, and then he should actually chase. But the patrol functionality is working. He's basically getting random locations. And then if we press Shift F1 to get out of here and go into the behavior tree, you can see he's basically locked into the patrol. And he's going to be basically just going through. He goes to a location, he waits, 3 to 5 seconds, then he patrols. Then he does that back and forth. So let's go back here, and we'll go ahead and stop this. All right, so what we need to do is, the reason that's not working is because we never set up the tagging inside the player object. So let's go back into our BP third person, double click, and then as the BP third person selected, you can just search for tag. And at the bottom, there's actor tagging there. We'll hit the little plus sign, and I think we called it player with a capital P. Compile, save. And let's go ahead and play this now. You'll notice it says I see you in the top left corner, but he didn't chase me. And he will chase me some of the times, like you see right there, he did. That has to do with the condition checks that we kind of set up, or that we haven't set up, I should say. So he sees, I see you, let me break line of sight. Go over here. And then after a while, he should kind of move back into his patrol route. Over there. Okay, so let's figure out why that didn't work. If we go back in the behavior tree, you'll remember that we kind of set up the has line of sight, but we didn't do anything with it. So that's where the kind of next topic of behavior trees comes in, is decorators, which for all intents and purposes you can think of as conditionals. I don't know why they named it decorators, but it's, I guess it doesn't matter. But yeah, any sequence, you can actually just right click, and then you can add a decorator, and we have a Blackboard entry we can use. So if I select Blackboard, I can then select that blue node, and I'm going to I'll give it a more appropriate name, like has line of sight. And then I want to select the Blackboard key entry. Currently it's referencing the self key, which is the enemy itself. That doesn't do us anything, so let's change that from self to has line of sight. That doesn't do anything either, because you need to change the observer aborts. The one we want to choose is basically both, but you have lower priority, self, none, as well as both. What this is saying is when I set it to both, everything in green, it's going to do when that's true, and then it'll abort everything else. Because what's happening is, remember the AI root selector, when I was telling you it'll only stop executing when it'll always stop executing when one of the children succeeds. The patrol is a child of the selector, and it was succeeding. So even though it saw me, because this is successful, it's not going to leave the branch. So if you set up this conditional and then you have this abort node, it'll abort a successful notification when this is actually true. So it'll basically jump it over here. So that's kind of like the difference between selectors and sequences. You got to be careful which one you're using, but you can still use conditionals to kick you out of a branch and move you into a different branch. And always remember the numbers on the side, because that'll help you figure out your order of operations there. So now that we have that set, we can actually go back and give this another go. When the player sees me, in the upper left hand corner it'll play the I see you, and every time you see that I see you, the enemy should turn and actually chase me, versus doing it kind of intermittently the other time. See? And it's using the navigation data, the nav mesh bounds volume, to determine where to walk to get around objects and stuff. So you know, Unreal's pretty powerful. You know, you have the behavior tree, which is doing the logic with the Blackboard, and then it's using the AI controller in conjunction with the nav mesh bounds volume to determine pathing. All right, everyone. I think we'll cut the video here, but I hope you found some informative value that you can take into your own projects. But as always, thanks for watching. Consider subscribing, and we'll see you on the next one.